Let yourself settle. There is nowhere you need to be for the next little while and nothing you need to solve. The lights can stay low. Your breathing can slow down on its own, the way it always does when you stop asking it to do anything at all. Tonight we are going somewhere very far away, and the strange thing is that getting there does not require you to move even an inch. You only have to drift and let the story carry you forward, further forward than you have ever let your mind wander before. We're going to the end of the universe, not the edge of it, because the universe may not have an edge. We're going to the end of its life, the very last of everything, and it turns out that the end is not loud and it is not violent, at least not in the way you might imagine. The end of the universe is quiet. It is patient. It arrives so slowly that nothing alive could ever watch it happen. It is, in its own enormous way, the most peaceful thing there is, so there is nothing here to fear. There is only a long, gentle unwinding, and you're welcome to fall asleep at any point along the way. Start with where we are. Right now, tonight, you are living inside the brightest chapter the universe will ever have. It does not feel that way, because the night sky looks dark and mostly empty, but that darkness is a trick of distance. Above you, scattered through the dark, are stars almost beyond counting. Our own galaxy, the Milky Way, holds something like a few 100 billion of them, and beyond it lie billions of other galaxies, each one its own swirling city of suns. The universe at this moment is full of fire. It is glowing in every direction, warm and crowded and young. Astronomers have a name for the age we are living in. They call it the stelliferous era, the age of stars. It is the time when the universe is dense enough and cool enough and rich enough with raw material for stars to keep being born. New suns are still igniting in great clouds of gas somewhere out there, even tonight, even as you lie here. Somewhere in a distant nebula, gravity is pulling cold hydrogen together into a knot, squeezing it tighter and tighter until the center grows so hot that it catches fire and begins to shine. That is happening right now. The universe is still making light, and it is worth remembering as we set out that it was not always this way. The universe began in darkness. In its very first moments, it was unimaginably hot and dense, a roiling fog of pure energy, far too chaotic for anything like a star to exist. As it expanded, it cooled, and as it cooled, the fog cleared, and there came a long stretch, hundreds of millions of years, when the cosmos was filled with nothing but cold, dark gas, drifting in a great unlit silence. There were no stars yet. There was no light to see by anywhere. Astronomers sometimes call this the cosmic dark ages, the long night before the dawn, and then slowly gravity did its patient work. The cold gas gathered and pooled and pressed together until somewhere in that darkness the very first star ignited, and for the first time in the history of everything there was light. Then another and another, until the dark ages ended and the universe blazed awake. So the story has a lovely shape to it. It began in darkness, it kindled into light, and tonight we are going to follow it all the way back down into the dark again. The universe is a single, enormous breath, a long, quiet inhale of gathering gas, a bright-held moment of stars and warmth, and then the slow, peaceful exhale that carries it back to stillness. We happen to be alive during the held breath, during the light. But here is the quiet truth that this whole long story turns on. The universe is not making light as quickly as it used to. The great age of starbirth has already passed. If you could rewind time by about 10 billion years, you would find the universe blazing with new stars, forming them many times faster than it does today. We were born late. We arrived after the peak, in the long, slow afternoon of cosmic history, when the fires are still burning brightly but the rate of new fires has begun, ever so gently, to fall. You do not need to feel sad about that. There is something tender about arriving late to a warm room. The fire is already lit. The hard work of beginning is over. All that is left is the long, comfortable settling, and you have a front row seat to all of it. The universe spent its youth building. Now it has begun, with no hurry at all, to rest. So let us follow it. Let us walk forward through time, gently, the way you might walk through a house at night, turning off one lamp at a time, until the whole place is dark and still, and finally quiet enough to sleep in. We are going to watch the universe grow old, and we are going to do it slowly because the universe does everything slowly, and tonight so can you. let us take the first few steps gently, while the numbers are still small enough to hold. Begin close to home, with our own star. The sun has been shining for about 4.5 billion years, and it is right now in the comfortable middle of its life. It is not going anywhere for a long time, but it will not shine forever. In another 5 billion years or so, the sun will begin to run low on the fuel deep in its centre, and as it does, something strange and slow will happen to it. It will swell. It will grow into a vast, bloated red giant, hundreds of times larger than it is today, glowing a deep ruddy orange, swallowing the innermost planets as it expands. And then, gently, almost tenderly, it will shed its outer layers into space in a beautiful glowing shell of gas, a thing astronomers call a planetary nebula, drifting outward like smoke. What is left behind at the centre will be the bare, hot core of the sun, a white dwarf no larger than the Earth, slowly cooling in the dark. Our own star, the source of every warm day you have ever known, will become one of those quiet cinders we will visit later in this story. But not for billions of years. Not for a very, very long time. And our galaxy will change too. The Milky Way is not alone. There is another great spiral galaxy nearby called Andromeda, and right now it is drifting toward us across the dark, slowly, steadily, drawn in by gravity. In about 4 billion years, the two galaxies will begin to meet. It sounds like it should be a catastrophe, a collision of two cities of hundreds of billions of stars each. But space is so vast and so empty that almost no stars will actually strike one another. Instead, the two great spirals will pass through each other, their shapes pulled and stretched by gravity into long, graceful streamers of stars, swinging apart and falling back together over hundreds of millions of years, until at last they settle into a single new galaxy, a great smooth ball of stars with no spiral arms left at all. Two galaxies becoming one. It is not a crash so much as a slow, sweeping dance, performed across spans of time too long for any eye to follow. Now reach a little further forward, to a time so distant it changes the sky itself. The universe is expanding, every galaxy drifting away from every other, and that drifting is slowly speeding up. Far in the future, perhaps 100 billion years from now, the galaxies beyond our own merged home will have drifted so far away, carried off so quickly by the expansion of space, that their light can no longer reach us at all. One by one, they will slip over a kind of horizon and vanish from view. A creature living in that far future, looking up at its night sky, would see only the stars of its own galaxy, and beyond them, nothing. No other galaxies, no distant lights, just its own island of stars, alone in an ocean of perfect black. It would have no way of knowing that the universe was ever full, that there were once billions of other galaxies blazing in every direction. The evidence would simply have drifted out of reach. The universe will quietly forget its own crowded youth, and grow lonelier without ever noticing. Before we go any further, we should talk about time, because the kind of time we're about to deal with is unlike anything your mind was built to hold. You measure your life in years. A long human life is less than 100 of them. You measure history in thousands of years, and that already feels almost too vast to picture, all those generations stacked one on top of another, back and back into the dark. The universe so far has lasted about 14 billion years. That number is already so large that it stops meaning anything. It just becomes a sound. And yet, compared to what is coming, 14 billion years is nothing. It is barely the first breath. The chapters ahead of us are not measured in billions of years. They are measured in trillions, then in numbers so large that a billion and a trillion sit side by side like two grains of sand, indistinguishable, both impossibly small against what follows. We're going to count past the point where counting means anything. And the gentle thing about that is this: you will never have to live through it. No one will. The numbers are so vast that they belong to no one. They are simply the slow ticking of a clock that no creature will ever hear strike. So do not try to hold the numbers. Let them wash over you like the sound of distant waves. Each new chapter will be longer than every chapter before it combined. The universe does not speed up as it ages. It slows down. It stretches out. Everything that happens further and further apart, until the events of the cosmos are separated by gulfs of emptiness so wide that the word patience could never describe them. This is the rhythm of the story tonight. Slower and slower and slower still. A perfect rhythm to fall asleep to. Here is one way to feel it, just for a moment before we let the numbers go. Imagine you could shrink the entire life of the universe, all of it, from the first instant to the final dark, down into a single day. Midnight at the start, midnight at the end. On that scale, the whole bright age of stars, the entire chapter we are living in right now, every sun that has ever shone or ever will, would all be over within the first tiny fraction of the very first second after midnight. A flicker. Less than a flicker. And then the rest of that day, all 24 hours of it, and the next day, and an endless succession of days beyond counting, would be nothing but the slow, quiet dark that follows. We do not live in the long part of the story. We live in the brilliant flash at the very beginning, the spark before the long night. Almost the entire existence of the universe is the dark and gentle afterward. And that means the warmth you know, the light you see when you look up at night, all of it belongs to the rarest and most precious sliver of all of time. You are living in the bright flash, you are part of the spark. Let us return to the stars and let us push forward in time. Far ahead of us the gas begins to run low. This is the first thing to understand about the long fade. Stars are made of gas, mostly hydrogen, the simplest and oldest material in existence, born in the first minutes after the universe began, and there is only so much of it. Every time a star ignites, it locks some of that gas away inside itself, fusing it into heavier elements, and when the star dies, only part of that material returns to the void to be used again. The rest stays buried forever in the cold cores the stars leave behind. So with every generation of stars, the universe has a little less to work with. The fuel is finite. The fire cannot last. Picture the galaxies far in the future, hundreds of billions of years from now. Star formation has slowed to a trickle. The great glowing nurseries of gas, the nebulae where new suns are born, have mostly emptied out. The brilliant blue stars, the hot, fast-living giants that burned through their fuel in only a few million years, are long gone. They were always the first to go. They lived loud and they died young, and now they are simply memories written in the chemistry of everything that came after. What is left as the gas thins out are the patient stars, the small ones, the dim red ones, and these change the character of the night sky completely. The universe, which once blazed white and blue and gold, begins to glow a deep, soft ember red. It is the colour of a fire that has burned down to coals, still warm, still alive, but mellow now and growing quieter, and somehow far more gentle to look at than the fierce brightness of its youth. Let us spend a little time with these small red stars, because they are the great survivors of the cosmos, and there is something deeply comforting about them. They are called red dwarfs, and they are by far the most common kind of star in the universe. For every brilliant sun like ours, there are many of these humble little embers, glowing faintly, burning so slowly and so carefully that they barely seem to burn at all. The secret of the red dwarf is restraint. A star like our own sun burns hot and fast deep in its centre, and in roughly 10 billion years it will exhaust itself and swell and fade. That sounds like a long life, and it is. But a red dwarf does something cleverer. It is so small, and its inner workings are so thoroughly mixed, that it can sip its fuel slowly and use almost all of it. Instead of burning only the fuel near its centre the way larger stars do, a red dwarf does not waste a thing. And because of that, the smallest of them can keep shining not for billions of years, but for trillions. Some of them will outlive our sun 1,000 times over. They will still be glowing, faint and red and steady, long after every star you can see tonight has gone dark and cold. There is something worth dwelling on in that steadiness. A world circling one of these little red stars would know a kind of stability that our own planet can only dream of. Our sun is a restless thing, slowly brightening over its life, destined one day to swell and swallow its inner worlds. But a red dwarf barely changes at all. A planet in just the right orbit, close enough to feel its gentle warmth, could bask in that soft red light not for billions of years, but for an almost unimaginable span. The sky always the same dull crimson, the warmth always the same, the star never aging in any way a living thing could notice. Generation after generation could come and go beneath that unchanging ember, and it would seem to all of them eternal. And when the end finally came, it would come so slowly that no single lifetime, no 1,000 lifetimes could ever perceive it. The star would not explode or collapse. It would simply, across trillions of years, grow a little dimmer and a little dimmer, fading by degrees too gradual to feel, like a lamp being turned down so slowly that the room never seems to darken at all, until one distant day, long after everyone who ever watched it has been forgotten, the light is simply gone. That is how the last stars die, not with violence, with a patience so deep it looks like permanence. Imagine that. Imagine a universe trillions of years from now, where the only lights left are these tiny, frugal embers, scattered thin across the emptiness, each one burning so dimly that you would have to be very close to feel its warmth. The grand cities of stars have dimmed to a scattering of candles, and then, one by one, even the candles begin to gutter out. The very last red dwarfs, the most patient stars that ever lived, will finally use the last of their fuel somewhere around 100 trillion years from now. And when the final one cools and fades, the age of starlight is over. The stelliferous era, the bright chapter you were born into, comes quietly to its close. After that, the universe enters a new chapter, and astronomers call it the degenerate era. It is a strange and beautiful name. It does not mean anything has gone wrong. It comes from the strange, dense kind of matter that now rules the cosmos. Matter so tightly packed that physicists describe it with that word, degenerate, meaning collapsed and compressed beyond anything in your daily experience. This is the era of the dead stars, the leftovers, the cinders of all the fires that once burned. And there are so many of them. Every star that ever lived leaves something behind. The small and medium stars, the ones like our sun, leave behind white dwarfs. A white dwarf is the exposed core of a dead star, an object with as much material as a sun crushed down into a ball roughly the size of the Earth. A single spoonful of it would weigh as much as a truck. When a white dwarf is first born, it is searingly hot, glowing white from the heat left over from the star it used to be. But it has no fuel left to burn, so it simply cools, the way a poker pulled from a fire slowly cools, over spans of time so long they are almost impossible to imagine. It fades from white to yellow to red, and finally to a cold dark cinder drifting in the black. A black dwarf, it is sometimes called. And here is something lovely to drift off on. The universe is not yet old enough for a single black dwarf to exist. Not one. Every white dwarf that has ever formed is still, even now, gently glowing, still cooling, still giving off the faint warmth of stars that died long ago. The universe has not had time to let even one of them go fully cold. The larger stars leave behind stranger things. A star much heavier than our sun does not fade gently. It collapses, and in collapsing it crushes its own core into something even denser than a white dwarf. It becomes a neutron star, a city-sized ball so impossibly compact that a single sugar cube of its material would weigh as much as a mountain. These neutron stars spin, sometimes hundreds of times every second when they are young, sweeping beams of energy across the cosmos like lighthouses. But like everything else, they slow down, they cool, they quiet. Given enough time, they too become dark and silent, just more cinders drifting in the growing dark. And so the degenerate era settles in. Picture it. There is no more starlight in the way you have always known starlight. There are no glittering galaxies blazing across the night. Instead, there are these dark, dense remnants, white dwarfs and neutron stars, drifting slowly through the emptiness, faintly warm at first and then not warm at all. The galaxies still exist, more or less, vast slow swarms of dead stars circling a common centre. But they no longer shine. They are dark wheels turning in a dark room. The universe has become a graveyard of suns, and it is a strangely peaceful place, vast and silent and almost completely still. But not entirely still. Even here, in the long dark, small things still happen. Now and then, two of these dead stars, two failed embers called brown dwarfs, objects that never had quite enough mass to ignite as true stars, will drift close to one another over unimaginable spans of time and finally collide. And in that collision their material combines, and for a moment there is just enough mass gathered in one place to spark a flame. A brand new star, born from the corpses of two that never quite lived, flickering into existence in the middle of the dark. These collisions are rare beyond rare. They might happen only a handful of times in an entire galaxy, across spans of time that dwarf the present age of the universe many times over, but they do happen. And so even in the graveyard, even trillions upon trillions of years from now, there are still these tiny fleeting sparks of light. A few last stars scattered impossibly thin across the dark, glowing for a little while before they too fade. The universe does not give up its light easily. It holds on to a little, right to the very end of this chapter. Let yourself rest for a moment inside this long, dim age, because there is a quiet beauty in it that is worth lingering over. Imagine a world adrift in the degenerate era. Long ago it was a planet circling a star, perhaps with oceans and weather and slow-turning seasons. But its star died and faded an eternity ago, and the planet has been wandering ever since, untethered, drifting through the dark between the dead stars. Its oceans froze solid not long after its sun went out, and then froze harder still, until the cold sank all the way to the core. There is no day on this world anymore, and no night either, only a single endless darkness broken now and then across thousands of years by the faint red glow of some distant surviving ember passing far away. The sky above this frozen world is almost empty, a few dim points of red light, impossibly far apart, and between them, a deep and total black. This is what most of the future looks like. Not fire, not destruction, but cold, quiet, drifting worlds beneath a thinning sky, growing slowly darker as the last embers fade one by one. And the strange thing is how peaceful it would be. There would be no storms, because there would be no warmth to drive them. No tides, because there would be no moon left in any meaningful orbit. No sound, because there would be no air that had not long since frozen to the ground. Just a still, dark, patient world, turning slowly in a still, dark, patient cosmos. Everything that ever rushed or burned or hurried has had its time, and now there is only the long, even quiet, stretching out in every direction and forward through all the time still to come. If there is a sound to the degenerate era at all, it is the softest sound imaginable. It is the sound of a universe settling, the way a house settles in the night into a deeper and deeper rest. Now we come to one of the strangest ideas in all of science, and it is the idea that begins to take everything apart. Until now, the dead stars, the white dwarfs, and the neutron stars have seemed permanent. They are no longer burning, but at least they are still there, solid and enduring, drifting cinders that could in principle last forever. But it may be that nothing lasts forever. It may be that even matter itself has an expiration date. The matter you are made of, the matter everything is made of, is built from tiny particles, and among the most fundamental of these is the proton. Protons sit at the heart of every atom. They are the bricks of all ordinary stuff. You, the bed beneath you, the planet beneath that, the dead stars drifting in the far future dark. And for a long time, physicists assumed that protons were truly forever, that they would simply persist, unchanged, for all eternity. But some of our best theories about how the universe works whisper a different possibility. They suggest that the proton may not be eternal after all, that given enough time, an unimaginable amount of time, a proton may simply decay. It may quietly fall apart, dissolving into smaller particles and radiation, ceasing to be. We should be honest and gentle about this because it is one of the great open questions. We have never actually seen a proton decay. Physicists have built enormous detectors deep underground, great tanks of pure water surrounded by sensors, and they have watched vast quantities of matter for years, waiting patiently for even a single proton to fall apart. So far, none has. This tells us something important, and also something soothing. If protons decay at all, they do it so rarely, so reluctantly, that the time it takes is almost beyond comprehension. The estimates suggest that a proton, if it decays, might last something like 10,000 trillion years before it does. Written out, that is a one followed by more than 30 zeros. You could watch a single proton for the entire current age of the universe, over and over, billions upon billions of times, and almost certainly never see it go. So there is no hurry. There is never any hurry in this story. But across the truly vast stretches of the degenerate era, those rare events begin to add up. In a single white dwarf there are more protons than there are grains of sand on every beach on Earth, more than there are stars in every galaxy, an almost unthinkable number. And if even one of them decays here and there, then over enough time, the whole thing slowly comes undone. The dead stars do not explode, they do not collapse, they simply, gradually evaporate. Each proton that decays gives off a tiny flicker of energy and a few light particles, and the great dense cinder grows imperceptibly lighter, atom by atom, across spans of time that make everything before seem like the blink of an eye. Imagine a white dwarf in this far future. It has been cold and dark for an eternity already, and now it begins to dissolve. Not quickly. Over a span of time, perhaps 10 million trillion years long, it slowly fizzles away into a faint warm glow and a drizzle of light, until at last there is nothing left of it at all. The same happens to the neutron stars and to any planets that might still be drifting around them, frozen worlds that long ago lost their suns. Everything made of ordinary matter slowly comes apart, returning to the simplest particles, scattering gently back into the void. The graveyard of stars empties out. The cinders are swept away, not by any wind or fire, but by the patient, almost invisible decay of matter itself. But we should be fair to the other possibility, because no one truly knows whether protons decay at all. Suppose they do not. Suppose the proton really is immortal, and ordinary matter can never simply dissolve. Even then, the universe has a slower, stranger way of taking everything apart, and it is one of the most wonderful ideas in all of physics. It comes down to the fact that, given enough time, almost anything that can happen will. There is a faint, almost unimaginably tiny chance that the particles inside any lump of matter will rearrange themselves, that the elements will very slowly transform, drifting toward the most stable form matter can take, which is iron. A grain of rock, a frozen planet, a cold dead star, all of it, across spans of time so long they make every number we have used tonight look small, would gradually, atom by atom, turn to iron. The whole universe of leftover matter would become a scattering of cold iron spheres, glittering faintly in the dark the last solid objects there are. And even those would not be the end. Over still vaster stretches of time, by the same patient, almost impossible chance, those iron stars would collapse, some of them slowly folding inward to form black holes, others quietly evaporating away. To write the spans of time involved, you would need numbers stacked on top of numbers, towers of zeros that no page could hold. But whether by the decay of the proton, or by these stranger, slower roads, the ending is the same. By one path or another, the ordinary matter of the universe comes quietly undone. And when this long dissolving is done, when the last white dwarf has faded into nothing, and the last neutron star has dispersed, the universe is left with only a few kinds of things. There is the thin haze of light particles and radiation left over from all that decay, drifting through the dark. There are a few stray particles, the electrons and their mirror twins wandering far apart, and there is one kind of object that does not decay, one kind of thing that the slow evaporation of matter cannot touch, because it is not made of ordinary matter in the ordinary way at all. The black holes remain. So now we enter the longest and darkest chapter of them all, the one astronomers call the black hole era. And the name is exactly right, because by this point in the unimaginably distant future, black holes are nearly the only things left. Everything else has faded or cooled or dissolved away. The stars are gone, the dead stars are gone, the planets are gone, the galaxies as glittering objects are nothing but memories. All that remains, scattered impossibly thin, across an emptiness that has been expanding for trillions of years, are the black holes. Silent, massive, utterly dark. You have probably heard of black holes as places of violence, as cosmic monsters that tear stars apart and swallow everything that comes near. And when the universe was young and crowded, that was true. They grew fat on the matter around them, some of them swelling to the mass of billions of suns, sitting at the hearts of galaxies, devouring anything that wandered too close. But in this far future, there is nothing left for them to eat. The feast is over. They have swallowed everything they ever will. And now these enormous black holes simply sit in the dark, surrounded by nothing, waiting. Except they are not really waiting, because nothing is coming. They are alone in a way that nothing has ever been alone, separated from one another by distances so vast that they will never meet again. Each one is its own universe of solitude. Each one is the last dark king of an empty kingdom. It is worth pausing to feel just how complete that emptiness has become. In our own time, Even the darkest patch of sky is not truly dark. If you could see in the right kind of light, you would find that all of space, in every direction, is filled with a faint, even glow. It is the afterglow of the birth of the universe itself, the last warmth of the great heat in which everything began, stretched and cooled by billions of years of expansion, until it is now only a whisper, a few degrees above the coldest possible cold. It has been fading and cooling this entire time, gently, steadily, ever since the beginning. And far in the future, in the age of the black holes, it will have cooled almost completely away, stretched so thin by the endless growth of space that it is colder than anything, fainter than anything, barely there at all. The first light of the universe, the glow of its very first moment, simply fades into the dark along with everything else. The cosmos forgets even how it began. And so the solitude of these last black holes is a kind of solitude that has never existed before and will never be matched. Each one sits alone in a darkness that has no warmth in it, no light in it, no other object near enough to ever reach. The space between them is not the friendly emptiness of our own night sky, where every dark gap hides 1,000 distant suns. It is true emptiness, growing wider every moment, stretching the distances between the last few objects until they are utterly, permanently beyond one another's reach. A black hole in this era could drift for spans of time longer than the entire age our universe has so far lived, many times over, and never come near another thing. It is alone with itself, in the dark, in the cold, in the silence, for almost the whole of the time that remains. And it does not suffer this because it cannot suffer anything. It simply is quietly, patiently, slowly giving itself back to the void. And here is the most surprising thing of all, the gentle twist at the heart of this whole story. Even the black holes do not last forever. For a long time, people believed they did. A black hole, after all, is a place where gravity is so strong that not even light can escape. Anything that falls in is gone forever. How could such a thing ever fade? But it turns out that black holes are not perfectly black. Very, very faintly, at the very edge of where they end and the rest of the universe begins, they leak. They give off the faintest possible whisper of energy, a slow, steady trickle of particles and light, drifting away into the dark. And because they are losing that energy, they are very slowly losing mass. Black holes evaporate. The trickle is almost nothing. For a black hole the size of one left over from a dead star, the glow it gives off is so faint, so cold, far colder than the empty space around it in our era, that you could never hope to detect it. It is the dimmest light there is, but it never stops. Drop by drop, across spans of time that make the entire history of stars look like a single heartbeat, the black hole gives itself away to the dark. A black hole with the mass of a sun would take something like 10,000 trillion years to fully evaporate. The giant ones, the ones with the mass of entire galaxies at their hearts, take vastly longer still, so long that to write the number you would need one followed by 100 zeros, a span of time called a googol of years. These are the longest-lived things the universe will ever contain. They are the final monuments, the last structures standing in the dark, and they too are slowly, slowly fading. Picture one of these last black holes near the end of its long, long life. For nearly the entire history of the cosmos, it has been losing mass so slowly that the change was imperceptible. But evaporation has a strange quality. The smaller a black hole becomes, the faster it gives off its energy. So as the eons pass and the black hole grows smaller, the trickle becomes a stream, and the stream becomes something brighter. After spans of time beyond all imagining, the black hole that was once the silent dark heart of a galaxy has dwindled to almost nothing. And in its final moments, after all those ages of patient cooling, it does something almost startling. It releases the last of itself in a final burst of light and particles, a quiet flash in the darkness, the last bright event the universe will ever produce. And then it is simply gone. Where the black hole was, there is now only empty space, and a few particles drifting away, and the dark. Think about what that flash truly is. For nearly the entire life of the universe, this black hole sat in silence, the dark survivor of a vanished galaxy, outliving the stars and the dead stars and the very atoms by spans of time beyond all reckoning. And in its final instant it gives back all at once the last of everything it ever held. It is, In a sense, the universe's final word, its last bright thing, a single small burst of light in an ocean of dark that has already swallowed everything else. There is no one to see it. There never could be. It happens in a corner of space so empty and so far from anything that the word lonely cannot reach it. And then the light spreads out and thins and fades, and the place where it happened is no different from anywhere else. The last candle has guttered out, and the great room of the cosmos is finally completely dark. One by one, across stretches of time so vast that the distance between one black hole evaporating and the next is itself longer than everything that came before, the last of them wink out. Somewhere, in some impossibly distant corner of an impossibly old universe, the final black hole reaches the end of its life and gives its last flash of light, and when that light fades, something happens that has never happened before in the entire history of existence. The universe goes dark, truly dark, not the darkness of night which is full of hidden stars, not the darkness of the degenerate era which still held its cinders and its rare collisions. This is a darkness with nothing left in it that will ever shine again. The last light has gone out, and there will never be another. This is where we arrive at the final chapter, and it is the quietest of all. Astronomers call it the dark era. It is everything that comes after the last black hole has evaporated, and it is, in a sense, the rest of time. Every chapter we have walked through tonight, the age of stars, the age of dead stars, the age of black holes, all of it together is just the brief, eventful opening of the story. The dark era is the long, long, endless rest. It does not have a chapter after it. It simply continues, on and on, with nothing left to mark the passing of time. What is in this final, eternal dark? Almost nothing, and that almost nothing is spread almost infinitely thin. There is light, but it is the faintest, coldest, longest light imaginable, stretched out by the endless expansion of space until its energy is barely there at all. There are a few stray particles, the last electrons and their mirror twins, the positrons, drifting alone through the void. Now and then, across spans of time that defy every word we have for largeness, one of these lonely particles might wander close enough to another to circle it for a while, the two of them spinning slowly around their common centre, forming the faintest, most delicate, most enormous structure that has ever existed, a single pair of particles bound across a distance wider than galaxies once were, and eventually even those will spiral together and quietly annihilate, giving off one last tiny flicker of light and then drifting apart forever into the dark. It is almost impossible to describe how slowly things happen here, in the dark era, because there is so little left to happen at all. In the bright ages of the universe, events came quickly. Stars were born and died across mere millions of years. Galaxies turned, light raced from place to place. But here, in the final dark, the events are so rare and the things left to take part in them so few and so far apart that the gaps between one happening and the next stretch beyond anything the word vast could carry. One stray particle might wander, alone, for a length of time longer than the entire age of stars before it ever meets another. And when it does, the meeting is the faintest possible event, a whisper, a flicker, and then nothing again for an even longer age. The cosmos is not racing toward its end. It has all the time there could ever be, and almost nothing to spend it on. And this is the gentle paradox at the heart of the ending. With so little happening, and the few events that remain separated by such enormous gulfs of nothing, time itself begins to lose its grip. Time, after all, is really just the measure of change, the difference between how things were and how they are now. When almost nothing ever changes, when a trillion years can pass with no event to mark them, then in a real sense those years barely pass at all. The universe drifts into a condition where there is no meaningful difference between one moment and the next, between an age ago and an age from now. It does not so much reach an ending as it gently dissolves the very idea of when. There is no final tick of the clock. The clock simply, softly, stops mattering. This is the state that physicists sometimes call the heat death of the universe, though the name is a little misleading, because there is no heat left in it at all. It is the coldest possible condition there is. What the name really means is that all the differences have evened out. Think of how a cup of hot tea left on a table slowly cools until it matches the temperature of the room. The heat does not vanish. It just spreads out until there is no longer any difference between the tea and the air around it, and once that happens, nothing more will ever flow between them. The universe is doing the same thing, on the grandest possible scale. All the heat, all the energy, all the structure that once made stars burn and galaxies spin, is slowly spreading out, evening itself across the whole of space, until at last there are no differences left anywhere. Nothing hotter than anything else. Nothing brighter than anything else. Just a smooth, cold, uniform stillness, the same in every direction, forever. And when there are no differences left, nothing can ever happen again. Every event you have ever known, every fire and every collision and every spark of light in this whole story happened because there was somewhere for energy to flow, something hot beside something cold, something bright beside something dark. When all of that is gone, when everything is perfectly smoothly the same, time itself loses its meaning. There is no before and no after because nothing changes. The universe does not end with a bang or a tearing or a collapse. It ends by becoming completely, perfectly still. It ends by going to sleep and staying asleep with no morning to wake to. I want to pause here, in the stillness, because there is something I think is worth saying gently, now that we have arrived at the very end. It might sound, when you describe it plainly, like a sad story. The lights all go out. Everything fades. Even matter, even the black holes, even the difference between one place and another, all of it dissolves into a cold and endless quiet. But I do not think it is sad, and I do not want you to drift off feeling that it is, because every ending in this story is unimaginably far away. Every chapter we walk through was longer than all the chapters before it combined. The dark is real, but it is so distant that it casts no shadow on anything you will ever know, or anyone you will ever love, or any morning you will ever wake to. And there is something else, something I find genuinely comforting. We are not at all sure this is how it ends. This story, the slow fade into cold and dark, is our best current guess, built on what we understand about the universe today. But the universe has a long history of surprising us, and there are other possible endings, and some of them are very different. The whole long fade we have followed depends on the universe continuing to expand, gently and steadily, the way it does today. We know that space is expanding. Every galaxy is drifting away from every other, and the expansion is even, very slowly, speeding up, carried along by something mysterious that we call dark energy. We do not really know what dark energy is. We only know its effect, that gentle, patient pushing apart of everything. And because we do not know what it truly is, we cannot be certain it will always behave the way it does now. If the dark energy stays as it is, then the slow fade is the future, the long cooling we have walked through tonight. But suppose the dark energy were to grow stronger over time, then the pushing apart would become more and more forceful, until eventually it overwhelmed everything. First the galaxies would be torn away from one another, then the stars within each galaxy, then the planets from their stars, and finally, in the last moments, the very atoms would be pulled apart by the relentless stretching of space itself. Physicists call this possibility the Big Rip, and it would be a faster and more dramatic ending than the long fade. But here is the soothing part. Even if it were coming, it would still be tens of billions of years away, far beyond anything that could ever touch us. And the evidence we have so far suggests it is probably not the path the universe is on. It remains a possibility, a what-if, a road not likely taken. Or suppose the opposite. Suppose the expansion were one day to slow and stop and reverse. Then everything would begin, ever so gradually, to fall back together. The galaxies would drift closer instead of farther. The universe would grow warmer and brighter and more crowded, running its history in reverse, until at last everything came rushing back together into a single point, in an event that mirrors the way it all began. Physicists call this one the Big Crunch. There is even an old and beautiful idea that out of such a crunch, a new universe might be born, a new beginning rising from the ending of the old, the whole story starting over again. We have little evidence that the universe will do this. The expansion shows no sign of slowing, but it is a lovely thought to hold. The idea that an ending might also be a doorway. There are stranger possibilities still, ideas so speculative that they live at the very edge of what physics will allow itself to imagine, where the rules themselves might quietly rewrite. But we do not need to dwell on those tonight. The point, the genuinely comforting point, is that the end of the universe is not written in stone. We are looking out across an almost infinite distance of time, trying to read the last page of a book whose middle we have barely begun to understand. We do not really know how it ends, and there is a deep peace in that not knowing. The story is still open, the final chapter has not yet been decided, so let us come back slowly from the end of all things, and let us land somewhere gentle. We have travelled further into the future than any thought has ever needed to go. We watch the last stars ignite, and the great fires of the cosmos burn low. We watch the dead stars cool in their long graveyards and slowly dissolve. We watch the black holes reign over the empty dark, and then, after a span of time too vast to feel, give up their final flickers of light. We arrived at the great stillness, the perfect quiet, the universe at rest. And we found, when we got there, that it was not frightening at all. It was only very, very far away and very, very calm. And now, having seen all of that, come back here, to this small warm moment, to this room, to the weight of your own body settling deeper into the bed, to the slow rise and fall of your own breathing. You are alive right now, in the brightest chapter the universe will ever have, surrounded by more light and more warmth, and more possibility than will exist in almost all of the time that is to come. The stars are still shining tonight. Somewhere new ones are still being born. You arrived in the warm part of the story, the lit part, the part that is full. There is something almost unbelievably lucky about that when you think of all the cold and quiet eternity that comes after. You are here for the fire. There is a kind of peace that comes from holding the very large and the very small at the same time. The universe will last for spans of time you cannot picture, and at the far end of all of them it will gently fade into the dark. And tonight, none of that is asked of you. You do not have to carry it. You do not have to solve it or fix it or worry about it. The end of everything is so distant that it will never reach you, and the only thing in front of you right now is rest. You get to be the warm, bright, breathing thing in the middle of an enormous calm. You get to fall asleep while the stars are still out. So let your thoughts drift now, the way the galaxies drift, slowly and without effort, each one carried gently away into a softer dark. Let the numbers fade. Let the eras blur together into one long, slow, peaceful exhale. You do not need to remember any of it. The universe does not remember either. It simply lets each chapter